this is now experiment 4, properties of solutions. So we will be learning about conductivity, solubility of ionic compounds, precipitation reactions, and we are going to determine water hardness of different water samples. So I have all the samples ready. The top one, I have water, I have magnesium sulfate, I have sodium chloride, glucose, ethanol, and then I also have acetic acid. And then the bottom, I have glycerol, and I have ammonia, ammonium hydroxide, I have hydrochloric acid, and I have sodium hydroxide, and I have 2 water samples, and those are rainwater as well as Lake Michigan water. So I have here the container, and this is a 24 well plate, and I'm gonna put 30 drops each of the samples, so I have 12 samples total. I'm now doing conductivity and acidity of solutions. That's part A, and I'm gonna do first A, which is conductivity of solutions. So I already put in a clean, dry 24 well plate 30 drops of each of the sample. I have 12 samples total. So I have in the 24 well plate over here, the top one, the first 6 samples from left to right, and then the bottom one, the next 6 samples from the left to right. So I also labeled it, this is my guide. So water, magnesium sulfate, sodium chloride, glucose, ethanol, acetic acid, and then glycerol, ammonium hydroxide, hydrochloric acid, sodium hydroxide, rainwater, and Lake Michigan water. So we will now test the conductivity. I'm doing now part 2, which is going to be the conductivity. So we will check this using a device called a conductivity meter. So this is the conductivity meter. I'm going to immerse the tip, the bottom, into the solution, and then I press high and see what the number will look like. So the higher the number, the more it's going to be conducting electricity. The lower the number, it's going to be conducting less. So for your part, you are going to record the observations. So in the report form, experiment 4, in the column, so the first column, I have the numbers, and then the solution, all the solutions, I have 12 samples, and then you are going to, the next column is going to be, you identify it either as ionic or covalent, and then the third one is going to be conductivity reading. So you are going to record what I'm going to read for each of the sample. All right, so that's the first experiment. So conductivity, acidity will be the next one. So conductivity of the solutions, that's what we're going to be doing first. So I'm pressing high. So this is the conductivity indicator or conductivity meter, and I'm going to dip it into the solution. The first one is going to be pure water. Okay, so pure water, that means it's actually RO water. So this is that sample, RO water or distilled water. And I'm gonna dip it. So I'm pressing the high. And as you can see, there's no reading. Okay, so just put 0. Okay, nothing. And then I'm now going to put it in the magnesium sulfate. So magnesium sulfate is the next sample, and it's actually the next one in here, magnesium sulfate. So I'm gonna press high and then dip it, and it's actually reading as 4. So it lit up at 4. Okay, Now I'm going to rinse this out because I don't want to mix up the solution. So I'm rinsing out the tip. So I'm gonna rinse in between and I will wipe it. So now the next one is sodium chloride, number 3 sample. Okay, so again, repeat. So sodium chloride is now reading as so I pressed the high, it's reading as 5. Okay, reading 5. Okay. Alright. So now I rinse again with a squirt bottle in between. And now the next sample is going to be glucose. So glucose is the next sample. Okay. And then I put here, so number 4 is glucose. So glucose, nothing. Next sample is ethanol. So ethanol over here. So now this is ethanol. So by the way, this is 95% ethanol. So it's the reading is 1. Rinse again. Wipe. And then the next sample is acetic acid. Okay. Acetic acid over here, number 6. And acetic acid over here. Press high. And now I'm reading it as 7. So the highest is 7. Oh, I think the battery. So let's do 6. It was 7 earlier, so let's just do 7. Okay? And then, so next I'm doing now glycerol. Okay, so number 7 sample is glycerol. And now the bottom. Okay, I press high. Nothing. Okay. And then next is ammonium hydroxide. Number 8. Ammonium hydroxide. I press high again. And then it's 7. Okay. Rinse again. Next is going to be hydrochloric acid, HCl. HCl over here in this solution. Okay, press high, dip it. Oh wow, it's so high. It's 10. Very high. Okay? And then we now have sodium hydroxide, number 10. Sodium hydroxide over here. Okay. Okay, so sodium hydroxide is the same, 10. Oh, it's 9. All right. Rinse again. And now we have the water, rainwater. So I collected these August 1st. And then rainwater over here. So again, it's this sample. Rainwater. I collected this overnight. Okay. So this sample here. Nothing. Okay. No reading. Right. Last sample is Lake Michigan water. So as you can see, there's actually still sand at the bottom, right? So Lake Michigan water, last row. Okay. Now, the last well in here, I press high. Oh, wow. That's interesting. 5. Okay? All right. So now we're done for that part, which is the conductivity reading. So that's the second column. Okay? We're now going to do the acidity. So the next part is we're testing acidity of solutions. It's going to be the third column, color of red litmus paper. So this is the red litmus paper. I'm going to dip this stirring rod and then put sample into the red litmus paper, and then we observe if the color change or stay the same as red. Okay, so the first sample is water. All right, so no color change. Okay, so I can use the same one for the other one. Because this is just water, I'm just going to use it again for the magnesium sulfate. Magnesium sulfate, same, no change. Okay, so again, rinse. So I will take out a couple of this red litmus paper. Okay, so I can use for the middle one. So I now have sodium chloride in here, and then I can put it here. So no color change for sodium chloride, same. So now we're gonna do glucose, number 4. So glucose, I dip it. No color change, same. And then, okay, and then we're gonna do ethanol. So ethanol, here, nothing, the same. And then acetic acid, so same, no color change. So now the next row is glycerol. So dip again, no color change. Next one, ammonium hydroxide. Okay, blue. So the red turned to blue. And then next one is hydrochloric acid. So I'm gonna put it on this side here. Okay, hydrochloric acid. Still the same. Red. And then one more. So now sodium hydroxide, NaOH solution here, blue. And then rainwater, nothing, stay the same. I don't have to rinse that out. And then last one, Lake Michigan water, same. So now let's review the color here. The one that changed into blue, red to blue, is gonna be the base, which is ammonium hydroxide and then sodium hydroxide. So the base, ammonium hydroxide, sodium hydroxide, turned red litmus paper to blue. The previous one was red litmus paper that I used. So I used the red litmus paper. And now I'm going to use now the blue litmus paper. Blue litmus paper. And then we are now going to fill up the next column, which is going to be the color of the blue litmus paper for the 12 solutions. So do the same thing. And now I will use 4 litmus papers. So it's blue. Okay. So first one again is water. Okay. Water. And pure water. So we're going to go down the list. Right? So pure water. Dip it. Okay. Stayed blue. Okay. Now I'm going to do magnesium sulfate. The same. Stayed blue. Now I'm going to do NaCl, sodium chloride, dip it, stayed blue. Next litmus paper, I have the glucose. Okay. Stayed blue. Next is ethanol. Blue. Next, acetic acid. Acetic acid turned red. Okay? We're now doing the next row, 7 down to 12, and then we're doing this row here. So glycerol, same. Next is going to be ammonium hydroxide, same, blue. And then next is hydrochloric acid, red. Last 3 samples, sodium hydroxide, blue. Rainwater, blue. Lake Michigan water, blue. So now let's review. So these are the results for the with blue litmus paper. So for the blue litmus paper, the one that turned red is the acidic one, which is the acetic acid as well as the hydrochloric acid. So acidic solution in blue litmus paper turned blue litmus paper into red. Is the opposite of the result for the red litmus paper. We're done for part 1, conductivity and acidity of solutions. Now you are going to classify each of the solutions as acidic, basic, or neutral. If it did not, if it changes color, you have to determine based on the results for the red litmus paper and for the result from the blue litmus paper, and then answer questions for part 1. So that's it for this part here. And now we're going to do solubility, part 2, and precipitation of ionic compounds. We're now going to fill up this table. So this is part 2, solubility and precipitation of ionic compounds, part A, observations. So you're going to write the observations and describe the appearance of a precipitate. So the first column are the names of the salt: potassium chloride, calcium chloride, cobalt 2 chloride, barium chloride. So I have here potassium chloride, they're all 0.1 molar, and then calcium chloride, cobalt 2 chloride is colored, and then barium chloride. Okay, so I also have here, so I put in this row all potassium chloride, calcium chloride, cobalt 2 chloride, and then barium chloride. Okay, and then I'm now going to add, so I'm going to add this solution: sodium nitrate, sodium bromide, sodium carbonate, sodium oxalate, sodium phosphate in each of the rows. Okay, so this is sodium nitrate, sodium bromide, sodium carbonate, sodium oxalate, and then sodium phosphate. They're all 0.1 molar solutions. Okay, so I'm going to add about, so this one is sodium nitrate, about 20 drops. I'm going to add 20 drops or 1 ml each. Okay, so sodium nitrate, I'm going to add sodium nitrate all the way down. And then we're going to observe. Sodium nitrate. Okay, sodium nitrate. So just want to be careful that it doesn't mix up with the other. Sodium nitrate. Sodium nitrate. Okay. And then I'm gonna stir it. So I have a stir stick, and then stir. Okay, I don't see any change. It's just a solution, clear. Okay, clear, nothing. And then I'm going to put it here. And then the next one, I'm gonna stir. So nothing, it's clear solution. Okay, and then the colored one is still the same, clear. When I mix together, and then the last one still clear. Okay, now we're gonna do now sodium bromide. Okay, sodium bromide. So on the next column here, so write the observation for the first one, and then now I'm doing this part here. So sodium bromide, I'm gonna add. Okay, so again, this is the pipette. It measures 1 ml here. So I'm gonna use this one. Okay, sodium bromide, the next column. Second one. Third. Fourth. Okay, so that's the sodium bromide solution. So again, I'm gonna stir it, stir stick, stir. Okay, next one. So it's still clear, the first one. This one same, still clear. And then the third one also clear, and then fourth one clear. So if I put it here, so we had already first row, second row, they're all clear. So I added sodium nitrate, I added sodium bromide. So we're done with that row. Okay, so I'm now going to do now sodium carbonate. Sodium carbonate. So third row is sodium carbonate. So we're now doing sodium carbonate. Okay, so 1 ml. Sodium carbonate, the third column. So again, stir stick. Stir the first one. Stir the second one. Third one. Fourth one. Right? So I'm gonna take it out. Here, you can see better. So I'm now doing this part here, okay? Okay? So the first one over here is the potassium chloride and sodium carbonate. Okay? This one is calcium chloride and sodium carbonate. This one, third one, is cobalt 2 chloride and sodium carbonate. So barium chloride and sodium carbonate. So this turned turbid white. This one became purple turbid. This one white. It formed a solid. Solid. Okay? So we're done basically with the third part here. Okay? The third part, we're now doing the fourth column. So we're now doing this part. So I'm now doing sodium oxalate. So the same thing, I'm going to add a ml. So a ml. First one. Second one. Third. Fourth. Okay? So again, stir it. Stir. 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 And then stir it. Okay? So let me take it out. Black background. So I see the first one clear, second one again white precipitate. The third one is starting. So if you compare this part, this and that one, this one is much clearer than this. Okay? And this one again white. Alright? So you can see the difference. Okay? So that's the fourth column. So we're done with the oxalate. Over here, we're now doing the phosphate. So sodium phosphate. Okay? And I'm doing again a ml. So the last column, a ml, a ml, a ml, a ml. So I saved these in case I need to redo. But now you can see, okay, this is now the last column here. Okay? And now you can see, okay? So actually if you go back to the original one, which is this part here, oxalate, so you can now see more precipitate at the bottom. So this is the sodium phosphate, potassium chloride, calcium chloride, cobalt 2 chloride, barium chloride. So you can see that you see precipitate here. It's now purple, white precipitate solution, and then white precipitate. So basically if you look at these here, So the last quadrant here, or the last nine here, are the ones that change. There was a reaction. So this part here, 1, 2, 3, 1, 2, 3, this part are the ones that change. So write down the observations, please. Okay? So we're done with this part, and now the next thing that you're going to do after you write the observations is now you are going to determine in this table. So this is coming from these. You're going to write now the cations and anions. Basically, you're splitting. So for example, potassium plus and then nitrate minus, and then the one that is forming is potassium nitrate. But so I said here that you don't have to put sodium plus and Cl minus because they all have sodium plus anyway and then Cl minus. You're just gonna put the ones that are not, that is the combination. So for example, for this one is potassium ion and then nitrate, potassium plus NO3 minus, and then you are going to now combine together to form a salt, which is potassium nitrate. You're gonna do the same thing for these and then the rest of the table. Part 3 is testing hardness of water sample using soap solution. So the procedure is I put 25 ml each of the water samples, and then I'm gonna add a drop of a soap solution. So you can see actually it has some bubble suds, and then we're gonna shake it and see and make a comparison, right? And we're filling up this table. Okay, so I have 5 samples: rainwater, Lake Michigan water, RO water. RO is reverse osmosis water, tap water, drinking water from PNW 3rd floor, drinking water, the water fountain. Okay, so I'm now going to add a drop of the 1% SDS is soap, and each of the sample I cork it and then I will shake. Okay, so I will now take out the cork and then add 1 drop each of the soap. Okay, right? So I actually added a total of 5 drops each of the soap solution. Okay, so I added 5 drops here, and now all of these had like 5 drops of soap, and I'm now going to shake it for 10 seconds. Okay. Okay, so again, seconds. Okay, after shaking the sample for 10 seconds, actually I shook more, maybe 20 seconds. So as you can see, the most suds actually on the drinking water, and then tap water, followed by the RO water, and then the rainwater, and then the least is Lake Michigan water. So again, the most bubbles on top, the drinking water in Westville, in the third floor of Swartz building, and then the tap water, followed by the RO water. This is our RO water, and then the rainwater, and then the least is Lake Michigan water. So that's the result for the testing hardness of water sample. So record your observations, okay? And then you are going to fill up the table. Fill up this table, observations, the amount of suds that you noticed after I shook it for 20 seconds. I actually added 5 drops of the soap. And then, so now answer this question: which sample is the hardest? Which one is the softest? So hard means that you have a lot of salt in the water sample. Soft is you don't have a lot of salt.